Hey everyone, welcome to our session, Security Everywhere, from Development to Deployment. I'm Michael Cade. I'm a field CTO focusing on our cloud native and cloud strategy. So all things Kubernetes, all things cloud stuff. So with the session, we want to touch on Kubernetes and the focus around security. So the first debunking of a myth that I want to kind of touch on is Kubernetes is not immune to malware, ransomware, cyber threats. I think regardless of whatever platform we're looking at, you're going to hear a lot about virtualization. You're going to hear a lot about cloud today, but equally around Kubernetes, we've seen if you're running an application there and you're running data, then the likelihood is that we're going to see some sort of threat around data that is living on that cluster. So what we really want to touch on here is, well, how do we prevent that? How do we then detect that? And then how do we remediate, or how do we recover when bad things do happen, and they will happen? So Kubernetes production demands more than just backup. It's never just about backup. If you're familiar with Veeam, you'll know that it's regardless of platform you're protecting. You have to consider the recovery, the security, and the freedom. And what do I mean by that specifically in the Kubernetes world is when we think about recovery, we're thinking about granularity. How do we bring back certain items of our microservice, for example? But equally, how do we look at disaster recovery if bad things happen, whether it be a cyber threat or whether it be accidental deletion or another failure scenario? So disaster recovery falls into that recovery piece as well. And then we've got security. So security being, how do we encrypt our data to ensure that the backups are safe? How do we make sure that only the correct access control rights are given out to our users, our admins? And then also, how do we make sure that those backups are in the most secure position as they possibly can, with immutability, ransomware protection added on to that as well? And then freedom, data freedom comes in very applicable to Kubernetes, because the nature of Kubernetes using these small containers that build up our microservices also enables us to move our workloads, our applications from here, there, and everywhere. So whether you're on AWS EKS, or whether you're on Microsoft AKS, or wanting to go between them, or Red Hat OpenShift, K10 gives us the ability to move that data freely, that whole portability story that no doubt you'll hear as well during the course of the day. So they're the three big ticket items that we want to now start to dive into. So in terms of the title of the session, Development to Deployment and Security Everywhere. So in today's world, where so many new applications, and there's meant to be by the end of 2025, 850 million new applications that are going to be developed. And we have to ensure that security is everywhere from a deployment and operations point of view, which I understand that the majority of us on the call will be focused on that deployment and operations side of the house. But equally, when we're developing software, we have to ensure that the application is free of any vulnerabilities at the time. We need to make sure that we're able to ensure or define policies so that we make sure that our application is built correctly. And then from a deployment point of view, making sure that we can leverage and integrate into authentication models around things like OpenID Connect and OpenShift and AWS IAM, as well as that ransomware protection that I touched on in the last slide around ensuring that we're sending our backups to an immutable backup location, such as AWS S3, any S3 compatible with the Object Lock API, but equally a Veeam repository that provides that same immutability. We can do that as well from a K10 point of view. Then if we get past that deployment phase, so that day 1 to day 2, and we've got the operations, within Kubernetes, there's quite a rich native API around role-based access control. So again, get into that least privileged, making sure that only people have exactly what they need to have access to. We can provide that and integrate that into casting K10, as well as being able to keep an eye out for the Kubernetes audit log to understand if anything bad is happening or an anomaly within the Kubernetes cluster, because then we might want to act upon that. And that might be a recovery that needs to be kicked off into a different cloud, a different location. So all of these come together, kind of forms that premise of the whole session. And no doubt you would have seen something from a Veeam data platform or a wider Veeam data platform, specifically around NIST and the NIST framework. And with K10, it's no different. It has a very similar aim for that. And it'll just call out some of these. So that image scanning, when we're building casting K10, we're obviously ensuring that those vulnerabilities are not in there, so that when we release our own application out to the public, it's safe and secure from day zero. From a protection point of view, being able to leverage that role-based access control, and some others on there that you'll see around encryption, immutability, policy-based app protection, and some of the others I'm going to touch on as well. Then where it really gets a little bit more enhanced around our story around data management within Kubernetes, and not just backup and recovery, it becomes the detect and the respond phase. So understanding if anything is trying to change the format of the backup file, namely in the object storage location, we're gonna be flagged about that. We're gonna see that. The backup admin is gonna see that, but equally about being able to integrate that into the likes of GuardDuty and ACS, regardless of what Kubernetes distribution that you're actually using. And then how do we respond? And as I mentioned around the audit log in there, in natively to Kubernetes, we have access to that, but equally around SIEM integration. So again, from a wider Veeam point of view, you'll hear SIEM quite a lot around integration. If in 2 weeks' time we'll have KubeCon in Chicago, you'll hear a lot more about 6.5, but I'm not here to tell you about 6.5 just yet. But you're going to see a lot more focus around that detect and respond, as well as the recovery phases when it comes to casting K10 6.5. And then recovery, as I mentioned, you've got Veeam Instant Recovery if you're using vSphere with Kubernetes on vSphere. Equally, the granular recovery, as well as disaster recovery as well. So all of the bases covered from a NIST framework perspective. So DevSecOps, think about that security everywhere, but we equally have to consider that principle of DevOps or DevSecOps around continuous security. K10 is released every 2 weeks, so we have to ensure that everything on our side that we're releasing is obviously secure and ready for public consumption. But equally, we want to make sure that we're going into environments where we're also fully secure. So this is a call for action for anyone running in Kubernetes. You can't skip this. This is a continuous effort to keep that security posture high and top of mind within our environments. And even though they're evolving daily, we have to consider how we can leverage these tools within our pipelines and to protect our environments, and more importantly, the data. So from a dev point of view, you've got, regardless of what experience you need as a team, so whether you're running GitOps type pipelines using Argo CD, or whether you're using OpenShift patterns to be able to ensure that continuous delivery of your application, or whether you've got your operation side and having that policy management, having visualization of that using Grafana, integrating into the wider Veeam data platform or Veeam backup replication from that perspective, you have to consider around security. And I'm going to touch on some of these areas as we continue to walk through this slide deck, but in particular around having visibility of the security policies that you have in place, as well as making sure that we're leveraging that native auditing and not just getting a wall of information that we can't do anything with. It has to be useful. Okay, so when we think about cybersecurity threats and attacks, we can use something from the US Navy that I've used quite a lot. If you do a search on your favorite search engine, and you search for Michael Cade and left of bang, you'll see a particular longer-winded story around this. But if we think about getting left of bang, the bang being the bad thing that's happened, and in this scenario, let's take that as a ransomware attack or a cybersecurity threat. So left of bang is about prevention, and then later on we're going to talk about detection, which is a bit closer to the bang, and then we've got remediation or recovery, which is right of the bang. So let's get into what does K10 bring to the Kubernetes data protection world when it comes to the ethos of preventing those attacks. So first and foremost is about our ability to integrate into the ecosystem, the security ecosystem. So namely, probably the two biggest names in the field around HashiCorp Vault and AWS KMS. And this is really about the ability to leverage this integration to look after those important keys when it comes to that recovery. Kubernetes native RBAC, I've mentioned this a few times, making sure that your users, your admins, have the least privilege. No longer should we ever be considering domain admin access for everyone. And then that immutability that I mentioned, not just immutability into a Veeam repository that you've probably no doubt heard already as well today, but the ability to send that off to object storage as well, natively from K10 to make sure that we've got a protected last point of recovery or last line of defense when it comes to recovering that data. And then these policy guardrails, in particular, I generally talk about projects from Kyverno or project called Kyverno and OPA, Open Policy Agent. So we've got the role-based access control, and that's going to grant access if you're a developer or you're an admin that's allowed to deploy an application. Then we can put some policies in place that say, okay, if you're going to deploy an application and it has some data, I want to ensure you're not allowed to run that until you've got a backup policy defined to that, and we're sending it outside of the cluster to an AWS S3 bucket in an immutable fashion. So these are just added points that we should be considering when we're looking after our Kubernetes environments. And then we get on to detection. So prevention should be way out. That line from the bang should be a long way away. Detection is a threat has come into the building per se, and now we want to. I need to know about that as fast as possible, but I need it to be clear and concise from that perspective. So today, this is about leveraging that Kubernetes audit log, as well as being able to understand anything that's potentially tampered with the backup file, understanding that. And this is also where you'll see a lot more of the effort that we're doing with K10 6.5 appear in the not too distant future as well. So being able to understand what is happening to the front end data so that we can make a better decision on the back end and the backup of that data, but equally the recovery as well, because we can use this to determine something's happening or we think something's happening, start the restore up in a different location so that we know that we can have that business continuity at that point. Okay, so bad things have happened, and now we're getting to that. The bang has happened, and now we're looking at that remediation or that recovery of that data. And I've mentioned this quite a bit, but the most important part for me here around this is the application mobility. How can I take, and this is the main premise of Kubernetes, the ability to recover to any supported cloud. So any Kubernetes distribution, I can take it from Kubernetes distribution OpenShift, for example, and restore that to EKS. And we have a transformation engine that enables us to do that. Now, that's not just for cyber threats and cybersecurity. It's a much broader use case, but it's very apt in this world. Then you've got granular artifact or granularity when it comes to recovery. How do we recover certain parts of our application that we need as fast as possible? If you think about a microservice is built up of many different container images, many different services, many different network policies, and a long list of other things. Maybe you only need certain aspects of that. Maybe you just need the persistent volume claim back because that data has been corrupted or encrypted that you haven't encrypted. And then we've got the full-blown failure scenario. How do I get that data from A to B in an orchestrated fashion into EKS from OpenShift because disasters happened? That's been cordoned off, and I now need to continue business over in a different location. And then, like I mentioned before, if you are leveraging Kubernetes on vSphere and you're leveraging the vSphere CSI, then you open up the door to a lot of the Veeam data platform functionality around instant recovery of those persistent volume claims. So being able to bring up your application in seconds versus waiting for that initial recovery to take place. To finish off, Kubernetes data management platform. It's very agnostic, very similar to the whole Veeam data platform, being able to support many different Kubernetes distributions, storage infrastructures, as well as data services. And the one thing I'll point out here is data services that are inside of the Kubernetes cluster if you're running operator-based databases or data services. But equally, if you're running things like Amazon RDS outside of the cluster, we've got the ability to also protect that using Kasten K10. And some of the more apt or talking points around this session is around the security services that hopefully I've touched on. You've got Kyverno, OPA from a policy guardrail point of view. You've got Red Hat doing a lot of stuff around that detection and prevention with their ACS tooling. You've got Vault and AWS around things like IAM, but equally around key management systems. I'd lastly like to just say thank you, and please reach out if you have any questions.